Hello, welcome to a short video on creating your own programming language and writing an interpreter for it using the fabulous Ohm JavaScript library. You can find Ohm at ohmjs.org. This JavaScript library helps you quickly build parsers, interpreters, compilers, and things like that. It has fabulous documentation, but more importantly, it has an online interactive editor in which you can design your language and build your grammar interactively, as all good designers would do. So let's get started. I'm thinking of a very tiny programming language, since this is a short video, a programming language that just allows me to print arithmetic expressions with addition and subtraction. You begin in the Ohm editor by adding some examples. So I'm thinking that being able to print the value 500 would be a good start, and I'll put semicolons in the language just for fun. Since I don't have a grammar, this is showing red, meaning this is not matched by your grammar, since the grammar is non-existent. Since this programming language is so small, I had someone once tell me that a good name for a very small language would be Piccolo, which I'll use here. And in Piccolo, program would be a sequence of one or more statements, which we'll use a plus for. And statements will look like, they will have the word print, it will have a left parenthesis, they'll have an expression, they'll have a right parenthesis, and they'll have a semicolon. What about expressions? For right now, expressions can just be numbers or numerals. And numerals, I'm going to say, will just be a sequence of one or more digits. The nice thing about Ohm is that Ohm has predefined digit as a predefined rule. It's telling you actually right here that it already exists, so we're good to go. In fact, our test lit up green, showing you that our grammar matches, and that's a good thing. But what we really want to do is add in addition and subtraction. So I think something like print, something like this minus this plus, that might be a good thing to try. And you can see that this fails right now, because I haven't implemented addition and subtraction yet. So expressions need to be more than just numbers. They need to be, for example, the sum of two expressions or the difference of two expressions. You probably pick up right here that Ohm has in it the idea of, well, I'm quoting things that appear in my language, like print and plus and the parentheses, and I'm not quoting the rules, the so-called non-terminals, as you might have heard them in the theory of computation class somewhere. Ohm just calls them rules. You can also see Ohm has some interesting notes here about alternations with inconsistent arities, because, well, this alternative for expression has three pieces, exp plus and exp. This one has three, and this one just has one. And in Ohm, we don't do that for reasons that we'll see very shortly. You need to mark rules like so that have, whenever you have a difference, here I have three, here I have one, they need to be marked. We actually have a test pass, but we have a tree over here that appears to be right associative. We have a right associative plus operator. Did I make it right associative? No, in fact, I did worse. I actually wrote an ambiguous grammar. I mean, there's no way of looking at this to tell if it's left associative or right associative. It just turns out that Ohm's internal algorithm makes it right associative, but we should not rely on that. In fact, future versions of Ohm are going to make this illegal. So let's get ourselves back into our tried and true left associative grammar. Well, we'll introduce terms here. And so this is kind of common in writing. I'll kind of assume that you're somewhat familiar with the idea that when you want to introduce left associativity into a grammar, a way that that's done, look at this, this has inconsistent arity again, so I'll mark it up with friends. Whenever you want to do left associativity, you make left recursive rules in your grammar and work your way down. So by saying expression plus term, you can see that our tree is working its way up to the right, from the bottom left to the upper right. is how this thing is working. And now things are working. We should introduce a couple more tests. We want to make sure that multiple statements can work. Print 2 plus something like this, minus. Yeah, so we can have multiple statements. Here's an example with 2 statements in here, just to show you that this thing over here is working. And it's a good idea to add as many tests as you possibly can. Make sure you've covered all the bases. Even try things that maybe don't work. Put in the letter E. Oh, sure enough, that does not work. You can see how that turned red. If you scroll down a little bit, I think you can see what the error is, right? It's the expected digit. Yeah, it's almost kind of nice when it comes to really telling you what you've done wrong. Which is a nice thing to have. So at this point right here, we actually have a grammar. Oh, in case you're wondering, see uppercase term, expression, statement, and program. These are all uppercase, whereas num is lowercase. If a rule is lowercase, Ohm calls it a lexical rule and does not allow you to have internal spaces. So I cannot have spaces in between numbers because that immediately goes bad. But I can have as many spaces as I want to between the components here of an expression, because expression is different. Just like I can have multiple spaces between statements because a program right here is a rule, not a lexical rule. It's what they call a phrase rule or a syntax rule. Okay, at this point right here, what do we have? We've got a problem here. We have a grammar. We have a grammar that works. What we'd like to do now is write an interpreter. So we want to get this grammar into a command line application. So let's do that right now. I have a blank folder for the Piccolo language. And since we're going to write a JavaScript program, I'll begin with npm init -y. That will create the famous package.json. This is a JavaScript program. Oh, and if you want to write modern JavaScript, don't forget type module. Otherwise, you're going to get that old style, unsafe, non-strict mode JavaScript, which are called scripts, but we want to do everything with modules. It's very important to do this. We're going to be using Ohm, so let's npm install ohm.js. We'll drop this in. You'll see it pop up, and there it goes. It just popped up all by itself. Thanks, npm. Now I think we're ready to write some code. Let's call this piccolo.js. So we'll just note it here, and we'll touch piccolo.js and create our file, which we've done. All right, we begin with import. We want to import the Ohm object from ohm.js. And that is good. All right, now we want to somehow or other use this Ohm object. And you can do many things with this Ohm object. But the first thing you want to learn about is its grammar method, okay? So with ohm.grammar, you take a grammar in the form of a string, and that produces for you an actual Ohm grammar object. And the Ohm grammar object can be matched and processed in many different ways. So let's grab this text of this Ohm grammar object, and I'll drop it in here. Save that. A quick tip, it's a good idea to, it doesn't really matter in this particular case, but in general, you want to use raw strings in JavaScript because it's very likely that your grammar rules are going to have backslashes. And it's nice not to triple, quadruple, and have just tons and tons of backslashes in there. So raw strings are actually pretty good. Let's take this Ohm grammar, store it in a variable, and just for fun, not that we have to, let's just see what it looks like, you know, just to get a little sense of what's going on here with Ohm. So let's run the program. And yeah, you can see that when I ran it, the grammar object is a JavaScript object with a name, something called the super grammar. And you can see it has some information about the grammar that we have. So Ohm basically gathered all this stuff up there and made a nice little internal object for it. Now, what do we do with grammars like this? Well, what do you do with grammars is you use them to check the validity of programs that you're trying to compile or interpret. And in OHM, what grammars do, or what OHM calls this process, is matching. Matching is the syntax checking and parse tree generation phase. So if I want to match, I can match a little program like, let's just drop in a little program here. I have one pre-made to save some time. So let me just drop it in here. There's a little program right here. If I wanted to match this thing, I get back a match object. So here's my match object. And one of the things you can do in O when you match something is you can say, did it succeed? So I can say match.succeeded. You can see it in the type ahead here, or I can ask if it failed. If it failed, we can just write out that there's a problem. We'll write out the match. Actually, what OHM does, which is really nice, is it makes it has a message field in the match object. So we'll just write that. Otherwise, let's go with a console.log. Yay, that'd be good enough for now. And let's run this. It says yay because it worked. If I had a problem in here, like, I don't know, I got a minus, but I don't have a number in here, and I will say this, and then look at the error message we get out. This is kind of nice. OHM tells us the line number and the column number. It points to where the error is, and then it gives us its very own message. So you know what? I mean, we got a parser, and the parser's done, and that's how the parser works. We should probably, just what we should do before we go any farther is, since we want to write a nice command line application, we should actually take our input from files, not locally over here. So let's create a new program. We'll call it example.piccolo. And then in example.piccolo, we'll put this program in here. It can have spaces, just like this, because, we want this to work. So I'll save it here. And then back in our interpreter, let's bring in the FS module from file system module from, I think it's just FS. And then rather than taking this whole thing in here, we'll say fs.read file sync and process.rb. So 1, 2 will be, that's just where and I believe this is, I think that's an array. Let's try this. Let's run it. Invalid arg type. Sorry, but what did we do wrong over here? Process.rb2. Dang it. Hey, when these things happen. Oh, it's a good place to try and fix stuff up here. This is just a stupid mistake. Must be a string. 0, 1, 2. Oh, I actually forgot when I ran the program. I think the program's actually right. I just need to say the name of the program. And then there we go. Now we have it. Okay, and let's make our thing work. So put in the value 1. And we're running. It says yay. So now it actually worked. Okay, so things work, but let's now actually write our interpreter rather than just saying, yay, we want to do something else. So how do you write interpreters? Well, in addition to having your grammar object match strings, a grammar object can also have on it something which processes the parse tree. And important OHM method over here is called create semantics. And create semantics lets you have operations and attributes details aren't terribly important, but I'm going to make an interpreter. So I'm going to make an operation called eval. And eval requires, as you see here, something called an action dictionary. An action dictionary is, what is an action dictionary? It is a list of, or a dictionary, I should say, of methods that are named after the rules in your grammar. And each of those actions does something. An interpreter will evaluate things. So I'm going to call mine eval. And let's build up this little action dictionary with our rules. So our first rule is program. Okay, so we're going to have some code in here for program. We're going to have one for statement. Okay. And what do these actions do? Okay, well, OHM is going to call each of these actions as it visits nodes in the parse tree. When it sees a program, it's going to say, hey, your program's made up of a list of one or more statements. So it's going to pass me in the statement nodes that it sees. When it comes across statement, it says, I found the print, I found this, I found EXP, I found right parenthesis, I found semicolon. So I'm just going to pass you the print keyword, the left parenthesis, the expression. It's going to pass in the right parenthesis, and it's going to pass in the semicolon. What about for expressions? What's it going to pass in for expressions? Oh, well, look, see how there's three things here, and one thing here? How many things do we pass in here as parameters to expression? Well, this is where this whole inconsistency thing popped up and why we have that particular error. That's because, well, how do we know if it's 3 or if it's 1? By marking alternatives that have different arities, different numbers of parameters, we can now do what OHM lets us do, which is say, all right, if you have expression and you decorate it over here with dash dash plus, what you really have is something called EXP plus. And we know that this takes in 3 things. It takes in left, takes in plus, and it takes in something on the right, right? It takes an expression over here, plus, and then it takes in a term. Minus works the same way. And what else do we have? We have term. Oh, wait, what about this term over here? Well, if there's only one rule right over here on an alternative, OHM will actually let it fall through. So if it's processing EXP and it sees that it's just going to fall right through. So we don't have to put anything in the action dictionary for these. For terms, we do have to put in term parens because there's 3 parts here. Term parens. This is going to have a left paren. You can see it has an expression in the middle of it. And then it has a right paren. Okay. And then for numbers, what do we have for numbers? We have just digits. So now it's going to take in its digits. And there we go. So our dictionary is set up, but I haven't actually made the actions do anything. And I mean, what should they do? Let's go middle out here. So I got an EXP plus. How do we evaluate a plus expression? Well, I think you just evaluate the left expression and then the right expression, you add them together. So we can say return evaluation of the left plus evaluation of the right. And let's do the same thing for here. For minus, return the left evaluation minus the right evaluation. Not so bad. Okay, what about for terms? Well, if we're interpreting, we don't care about the parentheses. We can just return the expression eval and making some progress on our interpreter here. What about for digits? Okay, num is made up of digits. Well, as it turns out, OHM has a number of different things that can apply to these parse tree nodes. One of them is called source string. Source string is the actual text in your source code that made up the contents of this parse node. So digits.sourceString will exactly be the string of digits that we found in our parse. And in JavaScript, you can always just apply number to a string to get an actual number. And then I can return this, and I now have the evaluation for a number. Syntactic number is going to evaluate to the actual JavaScript number when run. All right, let's jump over here. How do we evaluate a print statement given an expression? Turns out that's pretty trivial. Just log the expression evaluation. How do we do the statements? This is where things get a little bit tricky. Statements is actually a parse tree node. It's not actually an array of statements. It's a parse tree node. And that node has children. These are the actual nodes that are the statements themselves. So we could just iterate. We could iterate through here for const statement of statements.children. We just evaluate each statement.eval. And then I believe if we run our program here, let's go up, boom, it says yay, because we haven't actually connected the semantics object into anything. So we create a semantic object, but let's make sure it's assigned to something. This kind of is our interpreter, right? And here's how you do it in OHM. You would say interpreter, you would apply it to the match, take your semantics object, then you apply it to the actual match, then you call your operation on it, eval. And what we get here is a little error right here, statements.children is not iterable. What did I do? Statement eval. Oh, spelled it wrong. VS Code's trying to tell me I spelled it wrong. Duh. Okay, there it is. And this is our program. Does it work? 679, 14, 992. What's what the example is? 90, 92, 3 minus 9, negative 14. That looks like, yeah, I think we have it. And there you go. We've designed a programming language. We iteratively tested our grammar with the OHM editor, and we wrote a little Node.js program with the OHM library, and we now have an interpreter. That's it. Hope it was useful. Thanks.